Hi everyone. Today we'll be talking about RASA. Has anyone worked with RASA before except Ajay?
No.
Okay, cool. So basically, RASA is an open source framework which we can use to build conversational chatbots in very easy way. So we'll just directly start building and try to understand how the chatbot works. So to I've created a folder demo one and opened it in my VS Code. To create a RASA chatbot, first we need to install RASA. And to install RASA, we need to create a virtual environment so that all the dependencies or packages do not get messed up or interchange between the interpreters. So we'll create an environment first. We'll use Python for that. And to create an environment, the command is Python -m virtual environment dot backward slash and whatever name you want to give to your virtual environment. Then this command will create a virtual environment, and then we have to activate it. Activate, the command is just dot backward slash your virtual environment name slash scripts slash activate. And this command will activate your virtual environment. I've already created my virtual environment and activated it, so I'm not showing, I'm not doing it again. So once your virtual environment is created and activated, now you can install RASA. And you can install RASA by using the pip command. That is pip install RASA. If you just want the basic dependencies RASA, then you can just say pip install RASA. If you want all the language models or diet classifiers, everything, if you want in one install, you can give the command pip install RASA full. Or else you can just install RASA for now, and as per your needs, you can install all the packages later. This command will vary depending on the pip that you're using. If you're using pip3, then the command will be pip3 install RASA. So that will just install RASA. I've already installed RASA, so I'm just skipping this part. It will take a lot of time. Once RASA is installed, then we can just initialize or create a basic bot structure. For that, the command we can use is RASA init. This command will create like a basic bot structure which we can modify to make a bot. Do you want to train the model? Yes. So as you can see here, there are few folders and files created. I'll just explain what are those. So first we have the domain.yaml file. This is like the most important file. In this file, we define all the intents or the responses or any actions that we are going to create. Then we have the credentials file. In this file is used to basically connect your bot to external channels. Then we have the endpoints file. In this file, we can just add endpoints. If we are using actions, then we have to uncomment this actions endpoint, or any other endpoint if we are using, then we have to specify that in this file. Then we have our NLU file. NLU file is basically like the training data that we provide to the bot, which using which it recognizes the intent or whatever it is. Then we have the rules file and the stories file. Stories are the conversation parts, how the bot will respond. Suppose suppose the intent greet is triggered, then the utter greet action will be called. I'll just show you what is intent greet. We have defined intent greet here, and we have provided data for the greet intent here. Like if the user says any of this utterances, hi, hello, whatever, if the user says hi or hello, then the intent greet will be triggered, And once the intent greet is triggered, the action utter greet will be called. And utter greet was defined here. Utter greet. Hey, how are you? So that is how the stories work. And the rules, and we have here one more file, that is rules.yaml. These are the rules that the bot needs to perform without any prediction. Stories are like the responses might vary depending on the prediction of the bot. If the bot uttered saying how are you, then the user will respond whether he's happy or whether he's sad. If he says he's happy, then the intent mood greet will be triggered and utter happy will be shown. If the user says I am sad, then mood unhappy intent will be triggered and utter cheer up will be shown. So this and stories.yaml file is used for like making predictions and all. But in case of rules.yaml file, these are the strict rules. Whenever user says goodbye, then utter goodbye has to be shown. It can't show any other response. So that is how the bot works. Yeah, our model is trained. We'll just talk and see what it says. So our RASA server is running on port 5005. Mm, We can talk to it on the command line itself. Yeah. So suppose I say hello. So when I say hello, according to the stories, when I say hello, the intent greet is triggered. Once the intent greet is triggered, the bot will respond with utter greet. That is, hey, how are you? I'll say I am fine. When I say I am fine, it is not responding with anything. So we have to train. So let's just stop this. So before making any changes in the bot, I'll explain you some basic concepts of the bot. So first thing is like action and response. Action is a response from the chatbot based on the query. Like suppose now when we said like hello, the hello was a action and hey, how are you was a response. Then we have intents. Intents can be described as the aim or intention of the user input. As I said, like for hi, hello, good morning, good evening, etc. They can be treated as greeting intent. We can create as many as intents we want and provide training data to it. Then we have entities. Entities can be described as useful information that can be extracted from the user input. Like suppose we have a ticket booking bot created by RASA, and the user says, I want to book a ticket from Delhi to Kochi. Here, both Delhi and Kochi are entities. Like this is the location entity and this is the location entity. In this sentence, we can have like one more entity that is how many tickets we want. We can just define an entity number and then we can extract it using entities. Like suppose the user says, I want to book two tickets from Delhi to Kochi. Then the number two will be extracted as an entity. Then Delhi and Kochi will be extracted as entity location, and the number two will be extracted as entity number, which we can use later. Then RASA components. RASA has main two components, that is NLU and the RASA core. RASA NLU is the interpreter which processes the user input and identifies the intents and extracts the entities from it. And RASA core receives the output from the RASA NLU. Like suppose I say hey, then RASA NLU predicts that it is an intent greet. Then the RASA core, it is the responsibility of the RASA core to send a response to the user. Like the RASA NLU sends this thing to the RASA core saying that okay, I've predicted this intent as intent greet. Then it is the duty of the RASA core to send a response to the user, specify like based on the output of the RASA NLU. Like intent greet, then the output should be utter greet. So RASA core sends the output to the user. Okay, and now let's create our own intent and try to understand it better. So first, to create an intent, we need to define it in a domain.yaml file. Here we have list of intents. We'll just create a new intent, maybe weather. Then we need to provide some training data to the intent weather in our NLU file. So we'll just provide some data to our intent, that is intent weather, and we can provide some examples to it. Example like how is the weather today, or what is the weather, or the user can just say tell me the weather, or even he can just say weather. It will train the bot depending on the data we have provided. Then the next thing we have to do is we have to create a story path for that intent to be triggered. So we'll just create a new story here. Story, there we can say tell weather, and we need to provide steps for that story. Whenever the intent weather is triggered, then the bot should respond with some response. We'll say utter weather. Yeah, that's it. And this response also we have to define it in our domain file, like in here responses. We can just say utter weather and provide some text. Yeah, so that's it. Now before like testing the bot, we need to train it. And for training the bot, the command is RASA train. It will train the bot depending on the changes we have made. And this will take some time. By the time this is loading, I'll show you our actions file. Here we have an actions file, which we can use to like create custom actions, like to extra to make the bot more advanced or perform some integrate it with external services. We can use this actions file. This uses Python, so we can write our Python code here. We can even like integrate this bot to chat GPT. GPT-3 is not yet supported, but we can connect it to chat GPT-2 by making API calls in it. So let's just wait for this model to be trained. Here we have one more folder, that is models. This folder will contain all the models that we have trained. Suppose we train this model and test it. Then later on we make some changes and again train that model. Then here we'll have one more model. Just in case you want to go back to that model, like the previous model, then you can just access it from here. Okay, so our model is trained. As you can see, here we have our new model. So now we'll just test the bot. Uh, To chat with the bot on the command line itself, you can use the RASA shell. The command is just RASA shell. Okay, so our bot is loaded. We'll test it. We'll start by saying hello. Then how are you? I'm good. Great, carry on. Now we'll test our intent. Like how is the weather today? So when I say this, it should trigger the weather intent and give us a response. The weather is great today. Fine, it is working. Okay. Now we can even connect this bot to our web chat, and to connect it to our website, we need a chatbot widget. Rasa has few like open source chatbot widgets that we can use. We will be using the one which is like most easiest. We just have to download this chatbot widget in a local machine and open this index.html file. I've like already opened it here. So this is the chatbot widget, and to connect it to the Rasa chatbot, we need to like in a credentials file, we need to uncomment this REST thing. Rasa uses REST channel to connect with this particular chatbot. Every channel uses different things. Like Facebook, we have to provide all the credentials. Then Slack also similar thing. But for REST, we don't need to provide any credentials. We can just uncomment this and we'll be good to go. And we have to like use a different command to run the chatbot as to make the chatbot run to make API calls. And the command for that is rasa run enable API. Once the RASA server is running, it will run on the port 5005, and we can make like API calls on the port to receive and send messages on this port. So let's just wait for the model to load. Okay, so our RASA server is up and running. We can just open that index.html file in our browser, and here is our chatbot widget. We can test our bot here. So we say hello, then it will say, hey, how are you? I'll say, I'm sad. And the bot will say, here's something to cheer you up. Did that help? Yes. We can even test the intent which we created. How's weather today? We say the weather is great today. Fine. Okay, so let's move forward. Rasa has like recently released a new feature that is large language models. So first, let me tell you what are large language models. Large language models learn from a huge volume of data. As its name suggests, central to an LLM is the size of the dataset it's trained on. But the definition of large is growing along with AI. Now, large language models are typically trained on datasets large enough to include nearly everything that has been written on the internet over a large span of time. To like summarize it in like just a word, I can give you an example. Large language model like ChatGPT is an example of large language model. It is trained based on the data that is available on the internet, and it can respond to most of your questions. Not every question, but it can respond to most of your questions like from the data that is available on the internet. So basically, Rasa has introduced large language model, but this thing is little like slightly different. The main aim of Rasa to introduce large language models was to make the bot intentless. No, intentless in the sense, I'll just like use it and show you. So the main aim of Rasa to like introduce the large language model was to like skip this part. For example, now we created the intent weather, and we had to provide all this data to the bot, like training data, how is the weather, what is the weather, and all that stuff. But if we use the large language model, we don't need to provide all this data. and we don't even need to like define an intent here. We can just directly trigger the response. How to do it, I'll show you. Before using that, uh, before using the large language model, we first need to like include the pipeline. Here we can include some pipelines. I'll just uncomment these few. Main thing to use large language model, we have to use the diet classifier.
So
This
what
thing.
are these pipelines? What is this used for?
So these pipelines are like the large language model, but these pipelines are used to connect to the large language models.
Okay, so like RASA have already trained that model and we are connecting to that, or we
Yes,
train our own
like
model?
RASA is like already trained that model. We are just like using a pipeline to connect to it, and like we are using this diet classifier to connect to it. These
Okay.
are like language models. All this is the diet classifier which we'll be using. So we just have to like uncomment it, and we can use. And right now we had created a intent for weather. But if you are using large language model, we don't need to create an intent. We can directly we can directly specify a story in the stories.yaml file. Like suppose we can say user, whatever the user's input is, depending on that, perform a specific action. I can say what is the weather to. We just have to specify some user input and action what the bot will perform based on that input. We can test it. Before testing, let's train it. So just the difference is the main aim is to make the bot intentless. Like we don't have to remove all the intents completely, but we can remove the intents wherever they are not necessary. And whenever we are like using the large language model, when we specify the user input directly in the stories.yaml file, we don't need to provide any data for to train the model. It uses the pipeline to like diet classifier pipeline to understand the user input and predict the response. The model is trained. Just run it. Okay, our RASA server is up and running. So let's just test it. Neither we have provided any training data to the bot. Now we have created any intent. We have just directly specified the user's input. So we'll just test it. So I'll say, how is the weather today? So yeah, the weather is great today. Even if I say just weather, it should like give me that same response. Yeah. Even if I say something else, what is the weather? Yeah, it should give the same response. So yeah, that's it. And one more thing I forgot to tell about the actions file is if we are using the actions file, we have to run the action server also. And when we are running the action server, to connect that server to our bot, we need to uh, like specify the port number here in a uh, endpoint file, like the server number, action endpoint. We have to specify the URL where our action server is running. Yes, that's it.
So does this LLM get you the entities as well?
entities are like extracted using the other classifiers, diet thing and all that stuff. This is just to make the bot intentless. The main aim is to make the bot intentless. Instead of specifying the intents or providing large amount of training data, we can just skip that. Like I
And
can
just
even remove.
show
Sorry, sir?
and just show the like understanding of the usage of slots where you have some sequential conversation where you take the input from the user and based on the input you club them together and show the response. If possible, you can show that slots demonstrate.
Like slots are basically used to store the values of the user, either the whole user response or the entities that we have extracted. And to do that, we need to define the slots in our domain file. Slots, and we can just give the slot name. Maybe we'll just say number, phone number, and we'll just say a number. Then we have to like define the entity also for that thing.
Uh, let's ask three questions: name, age, and number.
So for name thing, we have to use the spacey and we have to like install that, and it is a very long process. Can we
Uh,
skip this name?
okay, let's skip that.
Okay, so for entity, for so basically this slot number is of type text, and it will be mapped using entity which is number. And this entity number, we have to provide some training data in our NLU file so that the bot understands what the entity is. We can just say we have to create an intent so to ask.
Can we also provide different variations of simple text, like what is
Uh,
your age?
yes, sir, we can. Usually, so we use forms to take input, like for multiple questions. If there's just one question, we do this. If there are multiple questions, we use forms. So,
Yep.
yes, sir. So here I can show like when the bot asks what is your age, then I said my age is 22. So here the bot is like extracting the entities as entity number as 22.
Yeah, that's nice. I
Yes.
think nothing else we can do. Thanks, Ryan.